It's not recorded. All right, so again, this is Unit 4, Lesson 3. There we go. Now, when we did our Hot Wheels tracks, how did we add energy to this little, what's this guy's name? Luigi? Luigi. How do we add gravitational potential to Luigi? Put him higher up. Now, did we just create that energy from nothing?
No.
Where did that energy come from to get him up there?
Your hand.
From my hand, which came from
Muscle.
my muscles, and that came from my breakfast. Okay, it ultimately comes, and then where did that come? It's all big cycle, so it doesn't come from nothing. So when we let Luigi go down our little ramp, right? When he's at the bottom of the ramp, he definitely doesn't have gravitational anymore, does he? What kind does he have? Okay, we converted. That's the idea of converting. Okay, the total doesn't change. We're going to represent that. Okay, just like we just talked about with Luigi example, roller coasters. We have a roller coaster that looks like this, which if you take physics, we go to Six Flags and study roller coasters. And then we ride them, because that's part of studying them. And so if you're up here, I think this looks similar to the Raging Bull. I don't know what roller coaster this is. Where does this thing have maximum gravitational potential?
Gravitational potential?
Gravitational, yeah.
Oh, at the top.
At the top. So, make this easier on yourself, put that little arrow up there, right there. Where will it have the maximum kinetic?
The bottom.
Down somewhere over here, at the bottom of the track. Right? It's just a conversion between the two. Alright, so there are two ways to represent the energy change in a system. Bar graphs and pie graphs. We're going to start with the bar graphs. Work our way through these. Okay, so here's our graphs. We're going to use our roller coaster example. You can kind of see it here, are our Hot Wheels example. Let me erase this here.
Or not.
All right, so now, where are we at when we look at this initially? We're at the top of the ramp, or top of the roller coaster. When we're doing our final, we're at the bottom. At bottom of ramp. Okay? Make sure you get that in your notes. Okay? Things that I put in here like that, you need to get in your notes as well. You add that in there. Right? It'll make more sense. Now, we're not going to put numbers to these. That's called qualitative learning. We're not going to put numbers to them. We're just going to look at the idea of it being conserved. In other words, it's just being converted. So like you guys already said, when it's at the top of the ramp, it's all... At the top of the ramp, it's not kinetic. How do we know that this is not kinetic when it's up here? It's not moving. But it does have height, so 1, 2, 3, 4. We'll give them 4 bars of EG. And again, that doesn't actually matter, just as long as you have the same amount in each. 1, 2, 3, 4. At the bottom, okay, he's going to have some speed, and he's not going to have any height. So that energy converted 1, 2, 3, 4. That. So it starts off as gravitational, and it ends up as kinetic, as shown there. And notice the number of bars in each are the same. That's the biggest thing when you do these things that you need to make sure that you do. Just keep those consistent. Any questions thus far? Am I tracking? See, it's not hard, is it? Okay. That's all you got to do for most of these, is just look at it, simple conversion. Like I said, my ideal is that everybody, I know I'm successful when the majority of my class passes the quiz on the first time. I know I'm teaching right, you guys are learning right, and know we're connected. All right, so here's another example. Lots of examples. Okay? Now this time, now in this situation, you have to look at the problems and decide what's going on. So this is a car that's going up a ramp. What's happening to his speed as he goes up the ramp? He's decreasing. So where is the car's maximum kinetic energy? At the initial or at the bottom? Initial or bottom. Where is the car's maximum potential energy? Gravitational potential energy. At the top up here. Because he's going there, and at this point it says he has 0 speed. So at the final. So now we're going to make a bar chart with that. Yeah, what's your question?
Here it says initials at top, but you said initial or bottom.
We just switched to problems. Which one's it? That's for the last problem. That's okay. So our problem now is okay. So listen. Here's the thing. Is now it's a new problem. This is our next problem. This is like problem 2. Okay? And so the car is now here, and he's already going. It's like the car is now going up the ramp and gets stopped. Does that make sense? Okay. So that's why I just switched those. Because it's all about reading the problem. You can't just memorize the same one for each one. You have to look at what's happening in the problem. But thank you for asking your question. That was a good question. So we're actually starting down here. It's already going. Oops. I got crossed by Luigi.
You did.
Stops up here. All right. So when we're doing our graph, initially, what do we have? Kinetic or gravitational? We actually have kinetic this time. And since we end higher, what do we have at the end? Gravitational.
Why is it 4 bars though?
You can make it 3 if you want. I just chose 4. You can make it 2 if you want.
It can be 1 if you want.
You can make it 1. Just as long as it's the same between the 2 pictures. These are fun. These are really fun. I just like drawing graphs. So.
I just find it easy.
Yeah, I hope you do. All right. All right. So now what we're going to do is pie charts. Pies look like pies. They're easier to distinguish between bars because bars have bars on them. So now what we're going to do is we're going to make a pie chart for the ball being dropped. Label your graphs with the letter wherever they match. Okay? Notice here we have 2. I'll turn off the light so you can see this better. We have 2 balls here. We're going to do this for both balls. All right? Ball A is a bouncy ball. Ball B, or this one here, object A is a bouncy ball. Object B is like a piece of silly putty. It's very similar to the sad and happy balls. One was able to bounce, one was not. All right, so let's go ahead and talk about doing the pies for the bouncy ball. All right, so the bouncy ball at position A versus B versus C. Now notice here, our pies are all the same size. You have to do your best, because the pies represent the total amount of energy, just like the bars, the different bars do. Wait for you to write that down.
Is that a Kit Kat factory?
What's that?
Never mind.
That is the Leaning Tower of Pisa, whatever it is.
No, I was talking about the power plant.
It is. But what'd you say? What kind of
It
factory?
looks like the Kit Kat factory on the commercials.
Oh, I don't think it is. It might be. I don't know.
Elon.
All right.
That's a quick.
So at position A at its high point, what kind of energy does it have?
Gravitational potential.
Gravitational potential. Now, here's how I'm going to mark gravitational potential. I'm going to call it E, G. Because it's a whole lot less, and I'll put that in the notes. That means gravitational potential energy. Gravitational potential energy. Why did I write it as EG? It's easier. Because I don't want to have to write out gravitational potential energy every time I want to go to write this out. This is a lot easier. EG, our GPE is fine.
What about?
Now, at position B, this ball is falling. What kind of energies does it have at that point?
B?
What's that?
Wait, did you say B?
At point B, yeah.
Oh, it's like both, right?
It is, very good. It's actually both. What are the both? So it's gravitational and kinetic. Very good. So at position B, we'll split this pie in half. We'll go EG, and then we'll go EK. It's half and half. Then finally, position C, the moment before it hits the ground, what kind of energy does it have? Kinetic energy, very good. And that shows the conversion between them. Okay, not too bad, is it? Pretty good. All right.
Pretty awesome.
Now, those are the kinetic and gravitational, but we're going to have other forms of energy that we include. So what does EK stand for?
Kinetic energy.
Kinetic energy. I'll write that there.
Do you want to know that?
Ah. Okay. Let's continue on. Now, what kind of energy would a fossil fuel plant use to create electricity? All right, so let me turn the lights off so you can see the picture. All right? We got lots of different types of energy, and I'll write them all down as we go. All right, so does anybody know what this pile is over here? Coal. All right? What kind of energy is stored in coal?
Chemical potential.
Very good. Chemical potential.
Oh, yeah.
Get it, girl.
All right. What are they doing here? What's that?
They're burning it.
They're burning it. They're heating it up to actually convert it. Okay. And that heat is being transferred into this tank right here. What's that tank? So when we're using heat, what's that called?
Thermal.
Thermal. We got chemical,
Jump here.
thermal. Okay, does anybody know, I don't know if you guys know this, they convert that, well, they heat that water and it transfers to steam. Does anybody know what the steam does?
Wait.
Hey Jordan, you got that flashlight? Can I use your flashlight for my lesson?
Yeah. I knew it was coming in.
Oh!
I just stabbed myself.
Alright. Alright, now. Actually, what to wear out.
There's a button on it. You gotta spin it like 15 times, then you push the button on off.
Go show them, Jordan.
It's somewhere on
I got you in the light. Oh, I see it. It's like, boy, hey, you act like it. Alright, so here we go. Now, we're creating electrical energy. I actually want to run down a little bit. Spotlight. Hopefully.
No cell phones.
So that's what the police officers do if you ever get pulled over at night. They have this really bright light. They take it and shine in your eyes like this.
it. How do you know Mr. Early been partying
Yes,
late night?
no, I've not been partying late night, but I do know, not the kind of parties you know about, but when they do, they shine. I've been pulled over at night though for speeding or whatever, or my license plate expired or something like that. All right, so how electricity is created is by, what am I doing?
Revving up the engine.
I'm spinning it. All right, so the steam has this thing called a turbine. They're not using, instead of using people's hands, or like I said, wheels, well, it is a wheel, but they're using steam to turn the crank. You can see it actually goes brighter as I start going. They actually use steam to turn the crank, all right? And that steam spins a set of magnets and a coil of wire, and we'll actually get into this later next unit, it actually creates the movement of the charges. Thanks, Jordan. Okay, so so it goes chemical, thermal. You heat the water, and it spins. What's the type of energy dealing with when you spin? What's that called? It's a motion. So what's the energy of motion?
Kinetic.
Very good. So to kinetic, and then from kinetic it becomes electrical. Yeah, I will. So it goes chemical, thermal, kinetic, electric. That's how you create power. That's how most of the United States is run on coal-based power. All right, so let's do the pie chart of that. Or you can do bar chart. Either way. Okay, where's my marker at? It's right over there. Where's on that side over there?
I do. Okay.
All right, so your pies. 1, 2, 3, 4. Hey, not done yet? Just finish strong. Last thing, we'll do the last example on Monday, and then we'll do the assignment class. All right, so we start off at chemical, potential, energy. I'll put potential energy. That's the coal. I'll put down here, parentheses, the coal. Thermal. Coal is heated. Coal combusts and heats water. It then transfers to kinetic. Water, the steam turns a turbine. And then it becomes electrical. Like that. So that's how you transfer from one form to another. That's just an example of all the different conversions. So put your binders away. We'll pick up here on Monday. That's a wrap.